most people left for the new year, right? I'm seeing many students around. Yeah. Okay, let's wait a couple more minutes and then we'll start. Okay, so quick announcements. Midterm is finalized. It will be 6th of April. It's Saturday, 2 to 4 p.m. Mark it down on your calendars. The exact venues will be announced, but the date and the time is fixed. So April 6th, 2 to 4 p.m. is our midterm. I guess you all get the announcement from Canvas also, right? So you should know that. I'm just reiterating. Midterm. Before that, next week, Monday and Tuesday, we'll have the 2 review lectures on pointers, references, etc. So this is next Monday and Tuesday, 8 to 10 p.m. at Lecture Theatre J. These are not mandatory. If you don't want to go, don't go. If you feel like comfortable, but you remember everything about pointers and references, you can skip them. And by the way, these will build on top of each other. You need to attend both. So the first one will cover something, and the second one will cover something else. Right? Independently of whether you go or you do not go to the review lectures, you must go 2 weeks from now, 2 Tuesdays from now, on a quiz we will have on pointers, reference, and constantness, constant variables. This is February 19th, Tuesday, 8 to 8:30. It's like a 30-minute quiz. Lecture theatres B and J. We will announce a sitting plan where you need to go. Remember, this takes up 5% of your final grade. So definitely do attend. All right? Any questions? Any general questions about the logistics of the class? Something that is not clear? Grading, assignments, labs, any questions from last time? All right, if you have any questions, send me an email. So this is pretty much the logistics, and now that this is out of the way, we will pick up exactly where we were last time. Okay, so the last thing we discussed last time was return by value and return by reference. So we're going to have a function, and it returns a value. It may not return a value, it may give me void, but if it returns a value, it can usually give it by value or by reference, and that's how it takes it as input, and we can use the same thing to return it as well. So return by value or return by reference. And as we discussed last time, it has to do with, this greatly differentiates how the function behaves, right? If I'm returning by value, the function will give me a new copy, entirely new copy of the variable, and whatever change I make in this copy will not affect the original variable, right? Whereas if I'm returning by reference, whatever changes I'm making in this one may modify the original object. Just reiterating, we discussed this all last time. This time, actually, we'll talk about the constantness. So, a main question that appears here is, okay, sure, I may want to return a reference, or I want to make pass a reference, but still I don't want to change the object. So let's see how we can do that. In C++, we have this very convenient const keyword, and it literally stands for constant. And the simplest way you can use it is when you're declaring a new variable, you can have const float, in this case, pi equals 3.14, etc., etc. So what this gives you is a value, is a variable declaration that will never change. It cannot change in the program, right? And some convention we have, it's not mandatory, but if you want, you can follow it, is that when we give constant variables, the identifiers we'll use are in capital letters. Like pi here is in capital. This is not mandatory, but many people use it like to separate easily constant from non-constant. All right? So, a different way to do it, to define a variable that is constant, and we used to do it a lot like this, is using this one. Everybody has seen something like this before? This is part of the preprocessor, the C++ module that runs before the compiler, essentially. Usually we put on the top of the file, right? And this one says define pi to be 3.1416. Does anybody remember how this works? Literally how it works? Anyone? When we give a define command to the preprocessor, the only thing that it does, it goes through the program, and literally wherever it finds this, it replaces with this, the actual representation. All right? So it would work. Why would I want to do something like this? Let's say I don't want to. Let's say pi appears 10 times in my program, and I don't want every time to say 3.1416. I'm just defining it like that, and I'm using pi instead everywhere. And the preprocessor will go and replace it manually. But do you remember, it's something I think you discussed in COM 2011. Why is this not a great idea? What's wrong? What could go wrong here? Anyone? This would work most of the time. In this case, this would work, but in general, it might not, right? So for example, somewhere in my program, I may want to use, I may have mistyped something and I want to use this as an integer. So there's no type checking. The preprocessor will just go and blindly replace this with this everywhere. But there's no type checking. So this might cause problems. And also this will affect the entire program. I cannot go and define pi somewhere else later, which might be useful for me. So in general, we don't use that, unless there is like something that's super hard-coded. In this case, in this specific case, you might use it, because pi is pi, nobody will change it, and that's it. But in general, we avoid it. Instead, we use this kind of declaration, and actually this is much more general. The const keyword may be used not only to say that a variable is constant, but more general objects, not only like, for example, numerical constants. Objects, pointers, or even member functions, class member functions. So it's a much more general keyword, and it can affect all of these things. And usually, we use it, and you should use it as a safety net. When you want to ensure that something will not change, right? When you want to ensure that something will not change, you should use this keyword. All right? So let's see. Here's an example. Let me zoom in a little bit. You cannot see from back there. Feel free to move closer if you don't have your laptop in front of you. All these are available on the website, by the way, right? So here's a simple program. It's not a full program. Actually, we could come up with a simpler example, I guess, but fine. We came up with this one. It defines a class. This is the header file. A class date. It has three private data members: year, month, and day. Integers. Could I use something else instead of an integer? If you wrote this program,
Sure.
can you?
Sure.
For the year, yeah, maybe. I mean, it depends on the year how you want to go. But something else?
String?
String also, but let's be more practical. What's integers? What do they give me? They give me numbers. From where to where? It would be negative also, right? So there's no way I'm going to get negative numbers. So usually, when you have something like this, unsigned, right? Unsigned means by default positive. And then we have our constructor. All right? It expects from keyboard the year, the month, and the day. And well, again, this is not a ready program. We're not checking anything. We're just blindly assigning everything. A lot of things could go wrong, but I just want to use it for an example. And I have a different constructor here that takes the three arguments as input. We also have an add month function. It takes the month and increments it by 1. And I have a difference that I did not write to board. The idea is it should take two different dates and give me the difference in days, right? And as a simple example, as a simple homework, you can try and implement it yourselves. It should take two dates, sorry, it would take a date and an extra argument date and calculate the difference. All right? And finally, I have one more, the print function that actually just is a very user-friendly print. It takes a date and it gives me the year, the month, and the day. All right? It prints the output. So this is my header file, and this is the implementation. Actually, this is my main. And clearly, we'll find together there are some issues with this code. Let's figure out what the problems are. So what is this doing? The idea of this program is it should calculate, and again, we did not implement the program, it should calculate the difference in days between the date World War II ended and today. All right? That's the idea. So the first thing it is doing is declaring a constant date, 1945, September 2nd, I guess. Or is that 9th of February? I'm not sure. I'm sorry, my history knowledge is not that strong. So it takes, and this is a constant date. It makes sense this is a constant, right? We should not rewrite history. This will not change anywhere in the program. This is fixed. And also it takes a new date today. And where will it read the input for this? From keyboard. It expects the user, it will run the first constructor, and expects the user to give it year, day, and month. And then it will print these two. So far so good. And then it should calculate in theory the difference between the two dates and tell me like there has been this many days since World War II. Okay? What if I want to calculate the difference until next month? And that's what I'm doing here. Saying take World War II, add a month, and calculate the difference in days by next month. All right? Is the program clear to everyone? What it should be doing? Okay? Let's run it to see what goes wrong, first of all. All right? So let's see. Okay, so I'm seeing one warning and two errors. So what is the warning saying? The warning just tells me, look, you defined this function in the header, you declared it, but you never actually defined it. And it's supposed to be a non-void function and it doesn't return anything. So maybe you want to fill it up. Remember, this is the difference function that I never wrote. So it tells me, look, you have something here that you never defined. This is a warning. Nothing goes wrong yet. This can run. What is the error? What is this one saying? In your own words, can someone tell me? Can someone tell me? Just try it. Based on what you read here, and this happens in this line here. I'm trying to call print on World War II. And this is a declaration of the function. So what could go wrong here? Just give it a shot. Yes?
Print is reserved.
Sorry?
Print is reserved.
Print is, no, it's not.
No.
It's not reserved, but yeah, there's something wrong with the function. But it's not reserved, something else. Yes?
You didn't specify it's that if you can change it if you don't put the constant.
Yes, that's what it has to do. Let's see. Here's a declaration of print. As we know, print will just print the output. It's not going to change anything, but we know that. The program, the compiler, doesn't know that. He sees a void a function that returns void, fine. But who knows? This function might be changing the variable. It's taking the caller actually. It might be changing this one, right? For some weird reason, inside print, I may have said, you know what? Change the year from whatever it is to 10 years later. All right? This in general should be fine, but remember that here we define date variable 2 as constant. As constant. So what happens here is that my compiler is complaining because it says, look, you have here something that's constant and you're trying to call a function that may change it. I don't know what it's going to do. And that's why it is complaining. All right? Is this clear to everyone? My compiler doesn't know what print will do. It might change this constant object and the compiler will not allow that. All right? So, how do we fix that? Anybody remember from last year? How do we fix that? How do I address this?
So you put const in front of in print function?
Yes, I somehow need to declare that print is a constant function. It's a function, that's a class member function that will not change any member data. All right? And how do I do that?
Void.
Yes. So here's how you do it. To indicate that a class member function will not modify a class object, and by modify the object I mean even its data members, we must add the keyword const right after the argument list. Look here, here's void print, argument list is empty, const, and then the body. All right? So that's what I need to specify. Clear? All right. And since I'm doing that, what about the difference? Remember, the difference should actually, calculate the difference between two dates. It should not change them, right? So I do the same thing for difference as well. Good practice. Whenever you're defining a new class and you're writing down, you're declaring the class member functions. If a function has no good reason to change the object that is calling it, then declare it a constant. All right? This is good practice in general. It saves you from trouble. It saves you from someone modifying your code later and changing something. It saves you from yourself. You might inadvertently change it later. All right? So can someone explain to me the difference between this and this? Const and const. So what's the difference between this const here and this const here?
The first one, so for the const that you pass
This
into
one.
the argument, then you're not supposed to change the object that you pass in.
Good.
But for the second one, you're not supposed to change any member.
Exactly. So what's this? We're using the same keyword here, the same bounding keyword, const, for two different things. Any class member function, ignore this for a second. Any class member function that has const right before the body is not allowed to change the class data members. Right? Anything that has to do with class data members, specifically of the caller object. All right? This one says that this is a constant reference. The input you will take will be a reference, different date, but you're not allowed to change it. So you're not allowed to change D in this case. All right?
So if you have the second const, should you still put the const in the argument?
Totally different.
Oh.
Let's see what happens when I run this. Let's see what happens. Sorry. Let's see what happens when I run this. Where is it? Yada. All right. So I will try to run this. Today, difference World War II. The fact that the difference function is declared constant protects this. The fact that in the declaration I'm saying take a constant reference protects this. All right? So if I want both of them to remain the same, I need const and const. All right? Clear? It may be the case that for some function I only want this to be protected, or only this to be protected, or both of them, or neither of them. All of these are possible. And by protected, I don't really mean what we mean by, I mean non-constant. Right? Constant, non-constant. All right. Good. So, in general, whenever I have a function that is not supposed to modify the caller object, I declare it as constant. And where do I declare it? Right between the end of the header and the beginning of the body. Any question? All right. So, this sometimes is confusing, so let's take it one at a time. What does it mean to declare a member function constant? It means that it should not change its caller object. So, if my object is declared constant, if I declare my object constant, as we did with WW2, World War II, we declared the constant, it can only call constant member functions. That is why World War II was not allowed to call print, because it was not declared a constant, right? But if I have an object that is non-constant, this can call anything. I declare a new object, a new date, I just declare it, I don't call it a constant. It might change later, I might decide to change it. So clearly this can call all functions, all member functions, right? If the functions happen to change it, it will change it. If the function is declared constant, it will not change it, but this is kind of an extra benefit. It could change it, but we decide that we don't want this function to change it. So a non-const object can call all member functions. All right? Is this distinction clear? When I'm operating from a constant object, I can only call functions that will not change me. They will not change the object. A non-const object, I can call any function I want. Now, this also has an implication on how this pointer is implemented, is materialized. So look what happens here. I have this function, date difference. I declare it to take as constant reference input, and it's a constant function. What does this mean? Remember, constant function means it cannot change the calling object. The calling object is exactly what this pointer points to, right? So when the compiler runs, essentially this function becomes this global function. Difference, constant reference same as before, and constant pointer to whatever is calling me. All right? So this is a constant pointer. If I remove this constant from here, this const here will disappear as well, which means that whatever object is pointed by this can be modified. And likely, it's exactly the same with print. If print is declared a constant, then this pointer that points to the object that called it points to a constant object. All right? Keep in mind what I said here at the top. Even if the object that is calling it is non-constant, this pointer for that object will become constant. The object itself may change, but not through this pointer. Okay? That's why we say that the object that is calling a constant member function essentially becomes a constant inside. Only inside that function. Okay. This is definitely confusing. I understand it the first time we see it. This is we're reviewing it from last semester. If it's not clear, go back and review it yourselves also. This will be also part of the quiz, something like this 2 weeks from now, right? So it can be very, very confusing. It's one of the most common bugs whenever you sit down and write a program. Oh, why is complaining? I'm trying to say something that is a non-constant, constant and run it through a non-const function. It happens all the time. All right. Now, to make things even more confusing, whenever I'm using a pointer, essentially there are two objects there, right? There is the pointer, and there is the object that it's pointing to, the actual value that it's pointing to. All right. And now there are all possible combinations. I may have a constant pointer pointing to a constant object, a constant pointer pointing to a non-constant object, a non-constant pointer pointing to a non-constant object, and a non-constant pointer pointing to a constant object. Yes, I know, even more confusing. Let's do it together. All right? So, yes, the syntax can be confusing. Here's the general rule. When you have something like this, And at this point, you really miss Python, right? When you have something like that, you're like, oh my God, I wish I was doing Python instead, or Java. So when you have something like this, a helpful rule is to start reading from the right, right? So here what happens? I'm declaring a character C, Y. I'm giving it the value, assigning the value Y to char. So this thing here is a constant pointer to a character. It's a constant, sorry, let me rephrase. It's a constant pointer to a character. All right? That's why we call it CPC. Constant pointer to a character. What about this? It's a pointer to a constant character. What about this? These are the same, right? If I write char const or const char, it doesn't make any difference. This is also a pointer to a constant character. Okay, so these two things here are the same. This is different. So what's the difference between this and this? This says my pointer is constant, all right? And it points to a character. What does it say? This pointer will always point to that location. Always. I cannot make it point somewhere else. It's a constant pointer. It doesn't say anything about the value in that location. I may want to change the value later. Okay? So the first one, you should do it like that. Here's my pointer. Always, this is fixed. This is like, imagine I have a lock here. Always points to this location. Whatever goes here, I can decide to change it later. But the fact that this pointer points to this memory address is fixed. All right? What about this one? This says I have a pointer to a constant character. I have a pointer to a constant character. This means here's my pointer. Here's the location it points to. Whatever is here is locked. There's no way it can change. But if I decide, I can then, at some point later, I can make this pointer point here instead. So the pointer itself is flexible, but not the value it's pointing at. The value it was pointing at is constant. All right? Okay, we'll do more examples, don't worry. But keep in mind that these two are the same. And keep in mind that we're reading, in general, it helps to read from right to left. Pointer to a constant character, pointer to a constant character, constant pointer to a character. All right? And finally, I have the even stronger version of this. Constant pointer to a constant object. And these are equivalent. Constant pointer to a constant character, constant pointer to a constant character. These are the same. Okay? Question on this. So keep in mind the difference. Sometimes where the pointer is pointing is fixed, then I have a constant pointer, and sometimes the value where it's pointing is fixed, which means that I have a flexible pointer and a non-constant pointer, but a constant value. Okay? Should we do an example? Okay, let's look at this. Although the answers are here. So here are two arrays of characters. All right? This is your usual initialization. This is what you learned last semester as C++ 11 uniform initialization. You can use the brackets for pretty much everything in C++ 11. Right? Okay, so what is this one doing? This is a pointer to a constant character, right? So I'm initializing a pointer to a constant character, and I'm assigning to it, essentially, s. All right? So look what happened here. S is not constant. I could go and change it if I wanted, directly. I can go and set the fifth digit to be E. But as far as this pointer is concerned, PCC, this is a constant character. Whatever it's pointing to is constant. So this pointer cannot be used to change it. So if I try to do this, set the fifth, well, the address of the fifth value that this is pointing to something different, I will get an error. Why? Because PCC thinks it is pointing to a constant object, right? A constant character. So this will give me an error. This thing here would work. This thing here would work. Remember, PCC is not a fixed pointer. It can go and point somewhere else. It can go from here to here. So I can now make it point to P. This would work. But you have to wonder when this is used, how useful it is, when you should do that, and so on and so forth. All right? Next one. This one is actually a constant pointer to a character. And I initialize this constant pointer to a character to S. This is something that's very important. Whenever you are initializing a constant pointer, you must assign it a value immediately. If you don't do that and you set it to null or don't do that at all, you're stuck. You have something that it's useless. Because it's constant as a pointer, you cannot change it later. Or you cannot assign it somewhere else. So, I'm assigning this constant pointer to S. So can I do that now? Yes, I can. CPC is pointing to a fixed location. It's always going to point to this. But this S can be changed because this is not a constant char. So I can do that. I can go and set this to 5. Essentially, it will go and replace this with 5. Okay? What I cannot do is this. I cannot make this pointer point somewhere else. Because this is a constant pointer, I cannot change where it's pointing to. Okay? And then finally, it's the simpler version in this case. I have a constant pointer to a constant character. So no matter if I try to change the value it's pointing to or the address, both of these will give me an error. Right?
I have a question.
Yes.
If you do like const, let's say the first one, const char
Yes.
pointer PCC, aren't you assigning the value of char array to the pointer and not the address? So you can do that.
So, sorry, what was the question?
Yeah.
Instead of doing this, what are you doing?
Address of S, because
For this one?
yeah.
Yeah, you could different way of initializing, right?
Oh, but like pointer shouldn't be storing the address of a variable instead of
Yeah,
the
yeah.
value of a variable.
Sure, but this is my initializer. I'm using this global initializer. This one knows that it should go and essentially do exactly what you're saying, but in the background, right?
Yeah,
That's
but
what this is doing.
yeah, but I meant like the address of a variable instead of storing the value of the variable.
Yes. That's what the pointer is doing essentially, right?
Okay.
But we have a way, C++ gives us a way to initialize this pointer like this. The effect's exactly the same.
Okay.
Alright?
Wait, but isn't the brackets just equals sign? Isn't it the same as equals sign? Or is it like equals?
It's essentially a new constructor for the pointer, right? That's what you're doing here.
Okay.
It's a way to initialize your pointer. Right?
I see.
Alright, so, other questions on this one? Good. So how many of you are totally familiar with this? Okay. How many of you took Comp 2011 last semester? Or Comp 2011 in general at some point? So most of you have not taken Comp 2011. Really, or you just don't raise your hand? I have not taken Comp 2011, for example. So again, this stuff has been taught before. This is just a review session. So go, if you're not comfortable, go and review it. Right? In Comp 2011, we did it in more detail. And also ask me questions. If I'm going too fast, it's not making sense, ask me questions. Okay, so one more thing just to clarify something. Here's my example. Ignore the header for a second. I'm declaring a new integer, I, 151, and I'm increasing it by 20. Right? This I can do because my integer is not constant. This is fine. So here I'm declaring a pointer to I, and I'm giving it the address of I as we were saying before, right? And I'm using this pointer now, I'm dereferencing it, I'm saying, look, go to wherever you're pointing at and increase that value by 20. This is also okay. Now I'm declaring a new pointer, PIC, and the difference is that as far as this pointer is concerned, it believes it is storing a constant integer now. It believes that it's pointing, sorry, to be more clear, to a constant integer. And I'm giving it again the address of I. Now if I try to do exactly what I did here, I try to do the same thing here, it will give me an error. PIC will complain, it's like, no, you cannot increase the value I'm pointing at. I'm pointing at a constant integer. Okay? So this cannot happen. The important thing is the following. Just because I did that doesn't mean that I somehow became constant. I itself can change. For example, if I go and run this line again down here, it will still work. The difference is that I cannot change I through this pointer. I can change it directly, I can change it through this pointer, but I cannot change it through this pointer. Okay? Now, let's see what happens next. This I can do also. I'm saying, look, pointer PIC, point to whatever pointer PI is pointing. Okay? And then I'm trying to run this, I get the same error. Again, I'm trying to manipulate it through PIC. PIC does not believe this can happen. All right? And the last one is kind of an invalid conversion. See how easy it was to do that? I have a non-constant pointer, and I'm trying to emulate whatever it's pointing through a constant pointer. This I can do. It's like when you take a read-only copy from something. Something exists, and you take a copy, but it's read-only. Fine, you can do that as many times as you want. But if you have something that is read-only, you cannot somehow make a copy that you can write at. And that's what we're trying to do here. I have a constant pointer, to an integer, and I'm trying to convert it to a pointer to an integer. And this will also give me an error. Is it clear why? Essentially, I'm trying to gain advantage, I gain privileges. Right? That's the idea. I had PIC. PIC is something I cannot modify what it's storing, and I'm trying to assign it to this one. If I was able to do that, then whatever this is pointing to, I would be able to modify. Kind of escalating my privileges, essentially, and this will give me an error. Yes?
Second to last example, if you assign PI to PIC,
Yes.
then you can't change the variable itself through the pointer of PIC, but can you change the object using the pointer PI?
Yes. PI directly, you can still change the object.
But PIC is pointing to PI, but you can still
Yes.
change the value.
It's essentially, you're always trying to reach the same goal, to change I. And some tools give you the ability to do it, some do not.
Okay, so, but if you assign PI to PIC, then they're pointing to the same object, but it's only that PIC, you can't change it.
Yes, PI you can.
Okay,
Yeah. Right. Good? All right. Now, okay, so, remember at the very beginning of the lecture I mentioned the passing by value and passing by reference. When I have a function, sometimes I pass it by value, sometimes I pass it by reference. And sometimes we want to be able to pass by reference, and there are two reasons for that in general. And these are two fundamental reasons. I mean, there are more than two reasons, but anybody based on your small or large coding experience with C++, why would you prefer sometimes to pass an argument as a reference instead of passing it as a value? What do you gain? Yes.
The object itself, so it's not a copy, so you can directly modify and change it.
Good. So you can directly modify it, yes. sometimes you want to do that. More generally, there are issues. So what happens when you pass something by value? Let's say I have somewhere an object, and I'm running a function, and this function takes this object as an argument by value. What will happen, C++ will take the original object, copy it, will create a new copy, and then run on that copy. All right? Sometimes this is useful, sometimes it's not. But imagine that you have an object that's like 10 megabytes large. You're storing a huge table somewhere. So your program will have to stop, copy 10 megabytes somewhere else in a new memory location. It will be a gigabyte instead. Right? And then run on that. So sometimes, even if you don't want to modify the original object, it's still too good to pass by reference just to avoid this whole machinery of copying variables around. All right? So that's one thing. And the second thing has, again, I mean, at least this, according to my opinion, these are the two main advantages. There are other advantages and disadvantages with passing by reference. Sometimes you pass by value, sometimes by reference. But the number one would have to do with this, avoiding the cost of copying variables around, especially large variables. And the second one has to do with this very inherent limitation of C++. If I went back in time, and I'm not an expert programmer, but if I went back in time and I was able to change something, maybe I would think about giving the ability to return more than one object. C++ returns one thing, always. All right? So what happens if I want to return 10 things? Or 20 things, or 30 things? Right? So the simplest way we have is, instead of returning them, we pass them by reference. So we have all these objects already, we pass them by reference, we modify them, and the effect is the same. We have the original objects, but now modified. The effect of the function took place. So, among others, these are probably the two most usual reasons to use pass by reference. All right? Now, as I said, sometimes, even though you're passing by reference, mostly to avoid memory cost, you still don't want to change the object. So in that case, we pass a constant reference. Okay, so we pass the input as reference, but with a const argument. It's exactly what we did in this example here. Look at the definition of the difference. It takes as input a constant reference to a date. All right? So it means it doesn't actually have to copy the date to a new variable, right? And also it will not modify it. All right, so it is again good practice that whenever you have a function that will take as input a reference argument, but it should not change it, declare this argument as a constant reference. All right? Let's look at this example. Let's say you have this function, CBR, called by reference. It takes as input a reference to an integer x. And then it increments x by 10. Fine. But if you try to run this instead, called by constant reference, it does the same thing, but here x is declared as a constant reference. This will give you an error. It will tell you, look, your function is trying to modify something that's supposedly a constant reference, and it should not do that. Right? So this can work as a safety net for you. When you're writing your functions, in general, you know what should and what shouldn't be modified, right? From the input and output arguments. So when you have an input argument that should not be modified, declare it as a constant reference. Which means that later, if you forgot what you were trying to do, maybe 10 days later or a month later, you're trying to change the function again, the compiler will complain and tell you, look what you're doing. You're trying to change something that you declare a constant. So make up your mind. Should it be a constant, or should we be able to change it? All right? And the second, advantage is that if you declare it a constant, a constant reference, this doesn't restrict you too much, because in general you can pass both const and non-const arguments to a function that requires a constant reference parameter. Why is that?
the fact that you declare the input argument as constant reference doesn't change the original thing. It just says, I will not modify it. The function will not modify it. The original thing may be non-constant. I just will not change it. Fine. All right? So it does not restrict you. The other way around, though, is impossible. If you have a function that takes as input a non-constant argument, reference, let's say, then you definitely need to give it something that's non-constant. You cannot run it with a constant. It's the other way around. The function says, give me something and I may change it. So if your original thing was a constant, this will give you also an error. All right? To better clarify that, let's look at this example. And I want you to tell me your opinion on this. Here are my two functions, called by reference, called by constant reference. They both take as input a reference to an integer. One of them takes it as a constant reference. And they do the same thing, they're just printing A. They're not changing it, but this is irrelevant here. So here's my main function. X, Y, X is an integer, Y is a constant integer. You now have 6 calls here. Which one of these do you think that will give you compilation errors when you try to run them? There are 2 that will give you an error. Sorry? Line 3 and line 5. Other opinions? Anyone that agrees or disagrees? No one? I think I'll give you a minute. You were very fast. I'll give them half a minute to think about it. Some of them will give you compilation errors. Anybody that agrees that it's 3 and 5? Anybody that disagrees, even more interesting. Let's make it more interesting. Anybody that disagrees? Okay, let's take them one at a time. What will this try to do? This is called by reference of X. It expects a reference to an integer, we give it an integer, a reference to an integer. This would work, right? Good. What about this one? What about this one? Will it run? Yes. What does it expect? It expects, it will interpret this thing, not expects, it will interpret whatever you put here as a constant reference. The fact that X is not declared as a constant is fine. The function doesn't care. The function is screaming, I will not change it. I don't care if I can, I'm so good that I will not. Alright? And this would work. What about this one? This is the opposite. So this will have a problem. Why? Might get the screen. So what's the problem here?
Because y is constant, is not supposed to change.
Yes. So y is declared a constant here. My CBR is a very privileged function. If it chooses, it might change a. For example, here I might have to take a and increment it by 10. And this will give me an error. It expects to be able to change y. Y is declared a constant. This will not work. What about this one? This again is fully compatible. I give it something constant, it expects something constant, it will treat it as a constant reference, it works. The original thing does not want to be changed, the function does not want to change it, perfect match. What about this? This is trickier. CBR 1, 2, 3, 4.
Because 1, 2, 3, 4 is not occupy them. It's not a variable.
Yes, exactly. 1, 2, 3, 4 is not really a variable, it's what we call a literal constant, right? So it takes a literal value and that's it. There's no way to address it, for example. There's no way to go and modify it somewhere. So I'm trying to run this through this. Let's say that again, this incremented. Inside here I had, take A and increment by 100. My compiler, my program actually will have an issue. Where does this thing live? Where should I go to modify it? How do I change it? So, literal constants, like this one, are also essentially treated as constants, right? So you cannot use them as input arguments for a function that expects a non-constant. Okay, keep that in mind. This is tricky sometimes. I think this was, back when I was a student, I think this was my first bug that took me like hours to figure out what was I doing wrong. This thing here. It cost me like 3 hours of my time. So hopefully it doesn't cost yours. So I couldn't understand based on the error I was getting what I'm doing wrong. And that's the problem. Alright? The last one would work fine, right? It's a literal constant. It it's not going to change it, so it's fine. All right? So 3 and 5 will give you a problem. All of these programs I'm going through, all of these small examples, we have them in the course webpage, right? If you go where we have the lecture slides, all the way to the right, the last column says code or program or something like that. Download it, run it, see what are the errors, etc., etc. Okay? Questions? Nothing. All right. So let's summarize all the things we discussed about constants. If you have an object and you do not intend to change it, declare it as constant. Constant is a tool you should be using against your own selves. All right? If you have a function and takes as input something that is not supposed to change, declare it as a constant. All right? This function is just printing this, so it will not change the object in any way, so we should declare it a constant. Why? Because it's good practice, because it helps us avoid problems in the future. Specifically in this case, we call it large object to stress the fact that this may be very large, this may be several megabytes. So I'll give it by reference, because I don't want to copy it, but still, this is a constant because my function will not change it. Question? Yes?
Does the compiler give a warning if the object path is large?
No.
Any kind of, so.
I mean, I'm not sure. I guess if you're
Okay.
probably if you run out of memory, you'll have less segfault issue, right?
Okay.
Yeah, not sure.
Okay.
We'll like define large. How large would large be?
I
To the
don't
point
know.
you run out of memory?
Yeah. Like, otherwise, how would we know? How would we make the decision
So this would not be the problem. No, what do you mean the decision?
whether to use and or not? Because the only reason we're using the ampersand is because it's a large object.
Not only, right? Sometimes we use it because we want to copy it. So it's good. It's an easy way to modify this object to this function. If I give it a reference. Otherwise, if I pass it by value,
Yeah.
this will create a new copy of the original variable. It will be modified here, but not change the original object necessarily, right? So the main reason to use use pass by reference is to find an easy way to modify this the original copy of this object. All the others is extra benefits,
Okay.
right? So objects that you don't want to change, define them as constant. Function arguments you don't want to change, define them as constant. And finally, the first thing we mentioned actually, if you have a class member function and you don't want to allow it, you want to prohibit it from changing data members, define it as constant. Declare it as constant, sorry. Well, how do I declare it as constant? Right after the list of arguments, I add the keyword const before the body. All right? Now, this is a small table to summarize who can call what. If I have a function, a member function, my original object is non-constant, it can call whatever it wants. All right? It can call all functions. They may or may not change it, it doesn't care. If my original object is constant, it can only call constant member functions. If my original object is declared as a constant, it means it cannot change. It should not be allowed to run these functions because these functions may change it. All right? Similar goes to arguments. Let's say I have a function that expects a constant argument as input. All right? Or here I have a function that expects a non-constant argument. If I have a non-constant object, I can put it either way. This is fine, non-const. This just means my function will not change it. Fine. But if I have a constant object or a literal constant, like the 1, 2, 3, 4 we said before, then there is no way to use them as input for this kind of function. Because this function expects non-constant. It expects to change them. All right? Okay, super confused. Who's feeling confused? I'm the only one that's confused here? Okay, for me at least this was a confusing topic. Any question? Nothing? Everything is clear? Okay, so what we'll do instead, I will not move to the next lecture, but what we'll do is this. First of all, let's take a look at the schedule. So we just finished this one. Review plus constantness. This is the first set of lectures, all right? The next thing we will discuss has to do with classes, constructors, destructors, all right? But what I want you to do is, in the meantime, I know it's New Year, it's supposed to be some time off, but you should study this. This has to do with makefiles. How we use makefiles to make our life easier for separate compilation, for different compilation rules, and so on and so forth. Okay, so makefiles are essential if you're building a large-scale project. You cannot compile otherwise. So this is self-study. This material we will not cover. There are two self-study sections, one on makefiles and one on namespace. I think these are the only two, right? Yes. So this is something you need to cover on your own. We will not spend time in class. I will presume you know them. If you have any questions about them, contact the TAs, open a discussion thread in Canvas, or email me. Hopefully in that order. Canvas first, then TAs, then me. All right? So, this is homework. For the remaining time, and we may finish a little early, depends on how good you are, there's something, there's another thing that's very useful in our website, and it's all the way down here, unfortunately. If I find it. Yes. We have this self-test section. Has anybody taken them? No one has taken the self-tests? I mean, it's too early. These are supposed to be for your own convenience, supposed to help you, right? So what we'll do is we'll do one of them now together, all of us together. These are not graded, this is just for your own understanding, right? Nothing to do with grades. So there are 9 different self-tests from C++ basics all the way to new features and so on and so forth. We'll do the second one now together on constantness, okay? And I really want you to be lively. If you finish this fast, you're going to leave earlier. Okay? So, there's I think like 8 or 9 questions. I would really appreciate if you have someone that can answer. You can try, and I don't want the same people to be talking all the time, right? So, give it a shot. So, question number 1. Here's a class. I have these 3 private functions. Which one of them is actually a constant class member function? Anybody that wants to answer, raise your arm and get the answer. Yes?
I don't get the question. What is...
So, actually, yeah, good point. This is a review of exactly what we taught today. So, I don't expect you to somehow magically have understood everything. We're just reviewing exactly the things we did. So, remember how we define constant class member functions are those functions that are not allowed to change data members of the calling object. Right? They're not supposed to modify the object that is calling them. Right? And we said that they are defined in a very specific way. Which one of the 3? C, right? We said that constant class member functions or constant member functions are declared especially in this way. Right after the list of arguments, you add the const keyword. What is this and what is this? What will this do? Return a constant integer, whatever that means. All right?
Can you elaborate on what that means?
Two questions later. What does this do? Yes, it takes a constant input, constant argument, which means it will not modify this thing. It doesn't say anything about the calling object. All right, so the answer, just to convince ourselves, is C. It's good. Now, let's look at this one. Let's see what's the question. Okay, so here are 4 definitions for A. And one of them, or more, we don't know, will not allow us to do something like this later. All right, so look at this program. I declare an integer b, 100, and here I have what? Pointer to a constant integer, pointer to a constant integer, constant pointer to an integer, constant pointer to a constant integer. All of these fun things. So, let's, there are 4 possible choices here. Let's assume I'm doing either 1 or 2 or 3 or 4, and then I want to do this. For some of these, this will work. For some, it will not. What do you think? 1, 2, 4 will not work.
3, 4.
3 and 4.
It does not allow assignment.
Okay, we have 1, 2, 4. Now this starts being more fun. I have 1, 2, 4, and I have 3, 4. Anyone else?
I think it's 1 and 4.
1 and 4. Oh my God, it's even more exciting. Does anybody agree with some of these? So you all kind of agree on 1 and 4 more or less, or maybe, we'll see.
I changed mine to just 3.
Just 3?
Yeah, just 3.
Okay. Anyone else?
Does not allow. The question is
Yes,
not-
does not allow, right? Which one of them will give you a bug, will give you a problem?
Yeah, just 3.
3 will give you a problem.
Yeah.
Okay, let's start with something.
Oh, wait.
Let's do something very naive. That's what I do whenever I'm not sure about a multiple choice answer. These two are the same, right? So they're either both wrong or both right.
I changed my answer.
Okay. And also let's do the other thing. Which one of them is the most restrictive? Which one?
4.
4, right? It tells you constant integer, constant value. So definitely 4. If any one of them has a problem, it should be 4, for sure. So would 1 be a problem or not? Would 1? Anybody want to try to guess, like actually justify if 1 would be a problem? This is a pointer to a constant integer.
Yeah, it should be a problem.
There should be a problem. Okay?
But the problem is by definition it's not because the code can let you do that,
Yes.
but the line itself is a problem, I think, because it's
Wait, you mean if you only have this, it will not be a problem?
Yeah, that's-
So this is true
that's-
for all of them. The question is what happens when you try to do this afterwards.
But wouldn't that line already be a problem because
This
B
one?
is not a constant, right?
Which one?
B is not a constant.
We're giving it the others. What is this one doing? It's initializing this pointer
To
and
a-
it's using the address of B. It's pointing to the address of B.
But it should be a constant, right?
Again, this is kind of the easy way around. You have something here that's not, you can modify it if you want, and you're trying to somehow create a new object that is read-only. This should be okay. The other way around should be a problem. Right? That's a general idea. Getting less privileges should be okay. Getting more privilege should be a problem.
Okay.
Alright? If this was a constant, and you're trying to access to a non-constant pointer, that might be an issue. We'll see. Alright, so let's sum it up. Who said 1, 2, and 4? Yay, first answer actually. 1, 2, and 4. 1, 2, and 4 will give you a problem. This will give you a problem. This will give you a problem. This will give you a problem. Alright? Why this will not give you a problem? Because this is actually protecting the pointer. Just the pointer is fixed. It cannot go and point to a different address. But I'm not changing the address, I'm changing the value. So this can be done. Alright? Good. Similar. Not exactly the same. Here I have a lot of, again, I will zoom in, but let's see the question. Which of the following definitions for pointer A does not allow later its redirection to point to another object? Before we were trying to change the value, now we'll change the pointer. Can be more than one. Okay, think about it and tell me. 3 and 4? 3 and 4? Anyone that disagrees? The answer is 3 and 4, right? Why? Again, this is constant pointer to constant integer. You should not even be allowed to change where it's pointing to. And this one's exactly the same. It says here is a constant pointer, which means this pointer A will always point to this location. I don't care what's inside, but it cannot go and point somewhere else. All right? Okay. More. Okay, so I have a function get string void, and it's declared as returning a pointer to a constant char. That's what it will return. Pointer to a constant char. Which of the following statements will compile and not give you an error? Which ones will compile and not give you an error? Okay, let's go with the easy one. One is obvious, I guess, right?
Second.
Yeah, the second one, right? That's what it expects. Fine, done. More. No one? Only B?
D.
D? B and D, or just D? Sorry? B and D. You agree? B and D? Anybody that disagrees? Why? So B is obvious, right? It expects a constant pointer to a constant character. That's what I'm giving it. Done. But why is this also okay? Anyone? You guys said B and D, right? So why?
When you initialize a constant pointer to something that you cannot change to a constant char. So essentially, when you initialize this constant pointer, you point it to something that you cannot change later.
Yes, through this pointer.
Yeah.
So the idea again has to do, at least that's how I find it intuitive, to having less privileges. This thing will give you a pointer to a constant character. It doesn't say that the pointer is constant. But when you're actually defining it like this, declaring this variable like this, and initializing it like this, I'm saying, look, I don't care that you will give me something that I may decide to change the pointer later. I will not change it. For me, this is a constant pointer. So it's even less privileged than what it's given. So this can be done. Okay? That's, at least for me, that's an intuitive way to explain it. All right? Okay, let's do this one. That's the one we had from before. What's the difference between these two? This is pretty simple. You have to get int functions, they take nothing, and they return an integer. A constant integer and an integer. Is there a difference, yes or no, and why?
For the first line, you have to assign it to a constant.
Mm-hmm.
And for the second line, you cannot, like if you are defining a constant integer, you cannot have the get int as the right value.
Let's play with it. That's a good starting point. Let's try to write this. Let's say I have the first, and I'm doing this. Will this work or not?
For which?
For the first one, let's say.
Oh. No.
For the second, obviously it will work. For the second? For the first?
First?
Yes or no?
No.
Why?
The x-axis is not declared as a constant.
Let's think about it. Will it run or not? Let's think about it once more. What is this one doing? It's returning by what? It's not returning a pointer, it's not returning a reference, it's returning a value. So how does return by value work? I'm copying my variable to a new value, right? And this thing is actually doing the same thing. It says, look, you see this constant thing over there? Just copy it and assign it somewhere else. This is integers, this is basic data types, right? So this is the equivalent of taking a picture of something. This picture that's there is a constant. You take a picture of it, and then you can go and modify it in your Photoshop because it's your own thing now. Right? So the fact that this is basic data type, integer, and it's returning by value, makes these two essentially the same. Right? Now, I have some issues with this question. This is general. This is true in this case, but it's not general always. So sometimes if these are member functions, member class functions, you might have issues, or if they're not returning integers and they're returning some specific data type that you define, some class, you may have issues. But for this specific case, these are virtually equivalent. All right? And why? Because this is returned by value. This will be assigned to a new memory location, and this will be copied to a new memory location. Okay? All right. Now, this one, which I think is a little bit confusing, but let's see. Here are two expressions. And essentially these are two instructions in the same line, two instructions in the same line. Only one of them is legal. The other will hit me and give me an error. Which one is legal and why? I'll give you a moment and then we'll discuss it. Okay, who thinks that this A is legal? One. Who thinks B is legal? 3, 4, 5. Okay, so most people think B. Okay, so one of you folks that said B, other than you, sorry, you speaking a lot, right? Someone else can try to say why B is legal? Your own words. So you just guessed B at random. So you want to try to say why A is legal? No? It's confusing, I'll give you that much. I think it is a confusing question, but let's do it slowly and we'll see. So first of all, we have here a new constructor, a new initializer. What does this do? Remember, new essentially creates a new memory location where it stores this thing here, an object of class A, using in this case, for example, the default constructor. And it returns an address. That's what this thing will. It's like a function. It will return an address where it located. Where this thing is located. So here we have a pointer to a constant object of class A, and we initialize it by giving it this address. All right. And later we try to say, look, here's a new pointer E. And let's assign it to C. So this is, as we learned, maybe you taught it last semester, we're actually going to learn it more about it. This is essentially a copy constructor. It's a copy constructor. It will try to say, look, do whatever this guy is doing. You are a new pointer, do whatever this guy is doing. Go and copy the data, for example. All right? And this will cause an error. This would require some sort of conversion, because this thing that I just initialized is a pointer to an object of a class A, and this one is a pointer to a constant object of class A. So this will trigger an error. Let's see why this will not trigger, and let's see why B will not trigger an error. I think that will be more helpful. So here, I have a constant pointer to an A-class object. So the object itself is not constant, but the pointer is constant. And I initialized it as before, and now I'm trying to say, look, create a new pointer and copy whatever C is doing. Right? And whatever you're going to point to is going to be an A-class object. But that's exactly what C is pointing to, an A-class object as well. So in this case, they're compatible. What is the difference in this case? If I wanted to modify this object, I could only modify it through, if I want to change one, if I want to change where B is pointing to, I could do that. If I wanted to change where C is pointing to, I could not. All right? Okay, and the last one, we're almost done. So, here's a class declaration. And here's the definition of one function. The class is called stack. It's a very basic stack as we did last semester, I think. So it has these three public functions: push, pop, get count. They're doing the obvious thing. This is putting a new object in, a new element in. This is popping the latest one and returns it by integer. And this gets the count of how many things there are there. And it has two private data members, an integer that's num, probably says how many things there are there, don't care, and the actual array that stores the data, 100 positions. And here's my definition for the getCount function. The getCount function. Now, don't care what it's doing. It's not really getting the count, but let's look at its side. It will do class plus num, will pop, and it will return the num. All right? So some of these will cause an error. Which ones are they? Maybe only one, maybe none, maybe more than one. Any ideas?
The most obvious one is the const class member function. It shouldn't be const, right? Because you're modifying.
This one should not be const. Right, but I don't get it.
Yeah.
So there's something related with the constantness here. That we all agree on. But the solution you're proposing is like, you know, my heart is in pain, I'm going to cut the hand. So
Are we supposed to figure out the errors in this code?
yes, not the errors, but what will give me back. Let's take a step back. This is actually very interesting. You said, look, this is constant, it should not be const because it's changing things. Usually it's the other way around. You declare it a const because you really don't want it to change things, right?
Oh,
Right?
it's getCount.
Yes. So it's a getCount function. It shouldn't change things. So it makes sense to declare it a constant. So see here, the difference between these three functions is that this one is declared a constant function, which means it should not be able to change the data members. So let's go now here and see what's the problem. Number one,
I have a question. Is there a definition of pop?
no, I haven't defined it yet, but you have the declaration, you have the header. I don't give you the definition, but you have the declaration.
Right. Then
Will-
both are problem. Both 1 and 2.
Both are problems. Everybody agrees? The first one is obvious, because it will try to increment this private data member, and because it's declared a constant function, it should not be able to do that. This is very explicit, this is obvious. The second one is less explicit, and you should be careful about things like this. What's happening here? This constant function that should not be allowed to change data members is trying to call a non-constant function. This non-constant function might try to change the data members itself. So as a function, getCount is responsible for all the calls it's making internally as well. So you cannot run this either.